Welcome to Study Loop.
We're considering transitions from the 3D to 2P state and ignoring spin. This never happens, but for this case, we're going to do it. So the 3D state, we have m sub L values of 0, plus or minus 1, or plus or minus 2. For the S state, we have 0 and plus or minus 1. And we're going to consider the fact that the change in energy, or the shifts in energy that we're asked to find, for the three different transition energy regions, so there's three different ones, are going to come from this delta E is equal to m sub L mu sub B times B, where this m sub L value is actually the change in m sub L. So we could say this is actually delta m sub L. So the transition. So for the first one, the 3D to 2P, right? We have m sub L from 1 to 1. Wow. We can also go from 0. And what other ones are the same in both? How about negative 1? Have negative 1 and 1. So all associated with the delta E value 0, right? And ML is 0. Going from 1 to 1, 0 to 0, or minus 1 to minus 1, there's no change there. Delta E is 0. Next, we're going to do the exact same thing. So we're going from the 3D to 2P. Again, so this time we want the delta E values to correspond to a positive mu sub B times B. In order for them to be positive, there's going to be a difference of delta m sub L equal to 1. So 3D has a 2 value. So going from 2 to 1, delta m is equal to 1. So these are all the m sub L values. So 2 to 1 is 1. You could also go from 1 to 0, because 0 is in a state in 2D. Another one. How about 0 to negative? And then lastly, the third option for 3D to 2S is a delta equal to negative mu sub B to B. Negative means the delta m sub L is negative 1. So the transition delta m sub L is going to be negative. So how about that's an allowed 3D state to negative 1. That's a transition. Negative 2 minus negative 1 gives you negative 1. How about negative 0? There's 1. And then the last one would be 0. Our final solution.